Today we're combining two things that people always search together: OSPF packet types and OSPF neighbor states, because on their own they feel like two separate lists that you're forced to memorize. But in reality, they are the same story, just from two different angles. So, neighbor states tell you where you are in a relationship, but packets are what you exchange to move to the next state in that relationship. So in this video, we'll walk the OSPF handshake from down all the way to full, and at each step I'll show you which packet type is doing the work. Hello, TBD, LSR, LSU, and LSAck. I will keep it conceptual, no deep field list, no authentication, and no commands. By the end, you should be able to look at the state progression and explain, we're here, so they must be exchanging this packet for this purpose. Now, here's the mental model for this entire video. OSPF wants routers in the same area to share a consistent LSDB, the link state database. Remember the pipeline from the previous video. Discover each other, decide who becomes adjacent, and synchronize databases. Then both routers can run SPF and build routes. So for this video, keep one phrase in your head: DB sync. DB sync is the main event. Neighbor states are basically the phases of getting to DB sync, performing it, and then staying stable. And OSPF packets are the tools used to discover, negotiate, compare databases, request missing information, then deliver missing information, and confirm delivery. That's the whole story. Now, let's define the 5 packet types in plain terms. But don't memorize just yet. You will see them in action right after. So number 1, hello. Discovery and relationship maintenance. I'm here. This is who I am. These are the parameters that I expect. And hellos do not carry topology. They create and maintain the relationship that allows topology exchange. Then DBD, database description. Compare databases, not transfer full details. Think of DBD as an index, table of contents. Here's a summary of what's in my LSDB. Link state request, LSR. Ask for missing pieces. I'm missing some entries. Send me those specific LSAs. Then we have LSU, which is link state update. Send the missing LSAs. LSU is the delivery truck of those missing LSAs. After that, LSAck, link state acknowledgement. This is just a confirmation of the receipt. OSPF wants reliability, so when you receive LSAs, you have to acknowledge that you received them. So the packet story is hello, meet and maintain, DBD, compare summaries, LSR, request missing, LSU, deliver missing, and LSAck, confirm. Now let's map that to the states. Quick but critical wording before we continue. LSA is the actual piece of topology information, and the LSU is the packet type that transports the LSAs. So if someone says LSU contains LSAs, that's correct. This will matter a lot when we hit the loading state. Now, we walk the neighbor state progression in order. Down, Init, two-way, ExStart, exchange, loading, and then finally full. And for each state, we'll do 3 things. We'll explain what it means, what packets you will see, and what problems that phase is solving. So let's start at the bottom. State 1, down. No relationship exists, meaning that you either haven't heard anything from the other router or you did previously but now you've lost contact. This is the default nothing is happening state. Packets involved is that you may be sending hellos but you haven't received a usable hello from them yet. So down is basically I'm shouting hellos into the void. State 2, Init. I heard you but you don't know me yet. Meaning that you received a hello from the other router, so you know they exist, but in that hello, they didn't list you as a neighbor. So it's one-way awareness. Packets involved are hellos, and the key idea is that Init is a one-way hello. Now, state 3, two-way. This means that we see each other basically. You have a two-way communication, you've received a hello, and the other router's hello includes your ID in its neighbor list. That confirms that we both see each other. Packets involved are still hellos, and the key idea is that two-way is the first stable neighbor relationship state. Now here's the big decision point. Do we stop at two-way, or do we become fully adjacent and sync databases? If the answer is stop, then two-way is as far as it goes. If the answer is become adjacent, then we continue. So mentally, a two-way is the fork in the road. Now state 4, ExStart. Let's set up the database exchange. Now we're entering DB sync territory, meaning that the routers have decided they will become adjacent, and they need to begin the database synchronization process. But before they start swapping database summaries, they need to coordinate an exchange process so it's orderly. Think of ExStart as, let's agree on how we're going to do this exchange. You don't need a deep negotiation mechanics here. Just remember that ExStart is the setup phase for DBD exchange. DBD begins here, but this phase is mainly about preparing the exchange. Now, state 5, exchange. This is where most people's understanding clicks. The routers are now exchanging DBD packets. But remember, DBD is a summary, like a table of contents, so in exchange, each router is effectively saying, here's what I have in my LSDB. The goal of the exchange is to identify differences, not fix them yet, just detect them. Packets involved is DBD mostly. But what's happening conceptually? Router A sends a DBD summary. Router B then sends a DBD summary. Both compare and build a list of LSAs that are missing or need updated. So exchange is just compare databases using summaries. Then the loading state. Now we sync for real. The meaning is that the routers now know what they are missing, so they begin requesting and receiving the actual LSAs to bring their LSDBs into alignment. This is the most direct mapping of packets to purpose. LSR is please send me these specific LSAs. LSU is here are the LSAs that you asked for. LSAck is I got the LSAs I asked for. So packets involved is primarily those three, LSR, LSU, and LSAck. Goal of loading is to get synchronized LSDB. So loading is basically request the missing, receive the missing, and acknowledge that you received the missing. State 7, full. Databases are now synchronized. That means that DB sync is complete. They now have a consistent LSDB for their area relationship, and they are fully adjacent. While stable, they keep sending hellos to maintain the relationship. And if topology changes later, updates happen again. Packets involved is hello, and they are used for maintenance. And if there is a topology change, LSU carries new LSAs and LSAck confirms receipt. So full doesn't mean no more LSUs ever. It means we're synced and we're maintaining, but if something changes, we will update. Now, these are the traps that most people fall into. 1. Thinking DBD packets contain the full LSDB. They don't. DBD is a summary, a table of contents. The detailed topology entries, LSAs, come in LSUs. 2. Confusing LSA with LSU. LSA is the content and LSU is the packet used to send the LSAs. 3. Thinking a two-way is always bad because it's not full. Two-way can be perfectly normal. Whether you go beyond two-way depends on the network design. Now let's compress the entire video into one clean chain. OSPF neighbor states tell the story of two routers going from no relationship at all to a fully synchronized database. First, down. Nothing heard yet. You're sending hellos, but you're not hearing them in any usable way. Then you go to Init. I heard your hello, but you don't list me as a neighbor yet. Then two-way. We see each other, the two-way hello confirmed, and this is the decision point for adjacency. Then ExStart. We're preparing to sync databases. Set up for DBD exchange. Then the exchange happens. We swap DBD summaries, table of contents only, just to spot differences. After that, loading. We request and receive what's missing. LSR asks, LSU delivers, LSAs, and LSAck confirms. Then full. Databases are now fully synchronized. Stable adjacency and maintained with hellos, and updates will happen if the topology should change. The big idea tying everything together is still one phrase, DB sync. OSPF states are the phases of DB sync. OSPF packets are the tools that you move through these phases. If you can tell that story smoothly, you don't need to memorize lists, you understand the flow.